Vittoria has just announced their brand new trail and enduro tyre. This is it, it's called the Mazza and it represents all of the new technical advancements in tyre design. We're talking different casing, we're talking armoured sidewalls, it's tubeless ready, it has progressive siping staircases, it has 4 rubber compounds, it's even got graphene in there to make it more durable. It really does represent cutting edge as far as tyres go. Now, I was supposed to be out in the States enjoying some stateside trails with the designer of this tyre, Ken Avery, but unfortunately, because of the fact that we've not been able to get there, we couldn't make that video. So we've had a little change of plan. Now, over the last fortnight, you've all been sending in some amazing detailed questions about tyre design and manufacturing. So we've put those questions directly to Ken and he answers all of your questions. Now, just bear with us a bit because the internet signal can be a little bit patchy, but I promise you it's really worth a listen. There's some great stuff in here and plenty of stuff I had no clue about. So how you doing, Ken? It's been a little while.
Yeah, man. Thanks for having me on. It's long overdue. We've been talking about this for a while, so it's good to finally tell the world about it.
Yeah. Of course, I've been riding the tyre, and we're gonna, in due course, tell all the viewers about it. But before we get started, tell us a little bit about yourself and what you do for Vittoria.
Yeah, I get called a lot of names, but basically my title is product and marketing, and I do global product strategy for mountain bike and gravel and a little bit in some other categories as well, and then as well as US marketing, and so it's kind of a bit to juggle, but it all kind of ties in together, and I kind of view all things from a rider perspective. So been doing this for about 20 years officially, and I've been with Vittoria for almost 10 years, and we've done a lot of things along the way, so it's been really fun.
Okay, so I'm going to put this straight to our viewers because we can talk tech all day long, and I thought the coolest way to do this is we're just going to answer all the questions that they wanted to know about tyres. Okay, so I'm going to hit you straight up with probably the most obvious question you can imagine, and it's how do you come up with a tyre tread design?
Man, it's a bit of a process, but really what it comes down to is first you got to identify the category, right? Are you designing a cross-country tire, an enduro tire, a downhill tire? What does that mean? And then beyond that, you have to say, what kind of terrain are you trying to overcome? So, all of these things come into play when you're talking about tread design, and tread design actually is also dependent on the compounds you're using as well as the casing construction. So all things must work in a system, and really, have to be designed to achieve the goal that you're trying to achieve. So for instance, if you're designing a hard pack cross-country tire or an all conditions enduro tire, they're going to be vastly different in terms of tread design. And you have to understand that from a rider perspective to really know what you need to overcome to do that.
I've noticed that there's some similarities in popular designs across the board from all manufacturers. I guess there's kind of just something in mountain biking. Designers find something that works and they sort of build on that.
Yeah, I mean, it's like anything. I mean, telescoping forks for the most part, right, are what you see. Bike manufacturers typically use a head tube angle that's going to be fairly similar. I mean, so there's going to be things that you learn along the way that are, become kind of standards. For instance, if you're trying to make the tire roll fast, you don't want to have a lot of spacing in the center, right? You're going to want to have something that doesn't create that vibration as it rolls. And also you're going to want to make sure that your casing is flexible enough to deform and not deflect off of bumps. As I've traveled around the world and ridden a lot of different places, I've learned kind of what works and applied it to different products. But really what it comes down to is, like I said earlier, overcoming the terrain that you're designing around and making a tread pattern that will roll as fast as possible, but yet provide the most amount of grip. And then also last. You don't want the thing to wear out immediately.
Okay, awesome. So next question then is dealing with the material of the tyre. So they're obviously made from rubber, but does it just come from trees or is there synthetic rubber? Is there maybe some sort of eco-friendly stuff coming down the line?
Yeah, well, I will say you guys made an awesome video when you came to our factory last year, and that just blew up and it was very informative. So I would encourage viewers to check out that other video as well. But the answer is we use both types of rubber. Rubber that comes from a tree is definitely something that's been a standard for many years in this industry, particularly. At the same time, you have some limitations inherently with that. I started mountain biking in 1991, and a lot of the tires back then used more natural rubber than they do now. We use a mix, and through our 4C layering compound application, we also use in certain places we use natural rubber. So it serves a purpose. It tends to be a bit harder and maybe not as grippy in the wet. So it's good for durability or reinforcement layers, things like this. But yeah, synthetic rubbers really have opened the door to really be able to do almost anything. I mean, you can really manipulate the elastomeric properties of synthetic rubber more and provide something that's going to roll fast and grip well, and then also last a long time. So for that reason, we use both.
Okay, and when it comes to making the tire compounds, there's obviously different durometers of rubber, but how do you create the different colors? A lot of people have asked in response to a post we put out, some old retro tires were like white and red and all sorts of crazy colors. And then there's also the tan walls and the black walls. What are those differences?
Okay, so this is a bit of a can of worms. We're going to start with the casings first, right? So when you're putting down casing and you're talking about nylon bias ply material, which is to say that the cords are 45 degrees bias, which provides nice stability in all directions, which works really well for a bicycle tire. This is different than an automotive tire. We'll get into that later. But when you first put that material down, it goes through a machine which looks like a big pasta maker. There's these two massive cylinders, and they squeeze rubber against this material and squeezes it into it. And really, the rubber goes into the material and forms the material of the tire itself. Now, if you want a tan sidewall, you just use tan rubber for that. I mean, it's really as simple as that. And that's fine for the casing. However, for the compound, back in the day, you used to see a lot more colored compounds. And it was because, compound technology wasn't quite what it is now. Now, it's funny, it's a double-edged sword saying that, because while things have advanced, there's also some inherent limitations with that. And the reason I say that is because, for instance, sometimes you use what's called a staining compound, which is, it must be black. And in fact, the sidewall must be black, because otherwise you'd have like the stain go down the sidewall. So, you can use colored compounds, but it kind of limits where you can have the performance characteristics that you may be looking for. And particularly if you're layering those compounds, because adhesion comes into play in different elements such as this within production. But, I love retro. I love all things. I have a splattered retro bike that I love. And so it's like, I'm near and dear to my heart. And I've definitely asked many times, what we can do with regard to that. But, when it comes down to like ultimate performance, the safe thing is black, and it's like I said, it's very difficult to make a colored compound that you can do all those other things with.
And you touched on automotive tires back then. Now, one of the questions was, why do mountain bike tires cost so much in comparison to car and automotive tires? Good question.
Sure, it's a great question and a valid question. I mean, we're all consumers of car tires as well, and so it's very easy to make that kind of alignment there. There's a few things. First of all, the automotive industry is massive. In some sense, cycling is still sort of a cottage industry, right? So Vittoria is actually one of the larger producers of strictly bicycle tires. We don't do automotive or anything else like that. And so we have a lot of research on this topic. The other thing to think about is that inherently a bicycle is a simple human-powered machine. And so the tires must be designed to be lightweight and efficient. And so with that comes higher end materials and things such as this that inherently cost more. So, you're using higher end materials and you're making less of them, price per unit is going to be affected. Lastly, I will say, in terms of just like the business model, oftentimes in the bike industry, there's sort of like a manufacturer, a distributor, a retailer, a consumer. And, oftentimes within automotive, one of those tiers of margin is not there. So sometimes the markup is less as well. So all of those factors come into play. Okay, cool.
So there's obviously a lot of lab work that goes on to develop the tires and the different compounds and all of the cool stuff that some of which I've seen. If lab testing and ride testing give all of the information needed, why isn't there a single best tyre and compound for each discipline or each surface? Why are there so many different types?
It's a great question. I don't want to answer a question with a question, but what is best? And what is best to you and what is best to me? And it's probably going to be a slightly different answer. And so you must have some sort of variation for whichever terrain you're trying to conquer, like I said earlier, but also riding styles. You could throw your shoulders an inch forward on your handlebars or your riding position rather, and it'll drastically change how that front tire feels potentially, and so you have to think about all these things. And with that, we definitely isolate variables as much as possible within lab testing. And we do a lot of lab testing, let me tell you. But at the same time, especially with cornering and with different types of especially looser terrain, there's really no substitute for real world testing in that way. And making sure that all the theories and all the machines that you made and all that stuff actually works when you hit the dirt. And, you could ride the same trail twice and those little rocks moved or the weather changed or whatever. And, it's really going to affect how things work in that way. So these things must be considered. And for that reason, I really believe that lab testing and real world testing complement each other.
Great
so
answer.
I don't know if that answers your question. But,
no, it does completely. The variables in mountain biking are one of the things I find very unique about it compared to many other sports. The conditions in one race in an afternoon, how dramatically they can change. Okay, so now with respects to performance on tyres, what is it that actually makes a tyre roll fast? And also, just having a faster tyre on the rear, I've always thought it makes a difference, but someone's asked, does it actually make a difference having the fast on the back and a grippier tyre on the front?
Again, fast is going to be a tricky thing to define, and I'm not trying to get out of the question, but truthfully, you could have a fast rolling tire on pavement, and then if you go into a loose terrain, it's going to your time, like if you're talking about fast means less time on a given circuit, right? Your time could actually increase in that circuit because you have less traction or capability in some way, right? So but basically it's not just about tread design, and this is actually the real answer to the question. It's about deformation and how the tire hits the ground when the casing deforms and engineering that deformation into it. So you have to make the tires such that the footprint can conquer the terrain. So for instance, on hard pack, the rubber tread is not going to penetrate into hard pack terrain or rocks or roots or hard surfaces, right? It's a surface phenomenon. It's going to be on top of those surfaces. So, but at the other end of the spectrum, if you're riding like in mud, your tire is fully in the terrain, right? It's not on top of the terrain. It's like in the terrain. So you have to think about how that's going to affect things. Now, a slick tire and back in certain conditions, sure. A slick tire is going to be fast as long as you're on the proper terrain and as long as your casing can still deform so that it doesn't deflect off of bumps. So Vittoria is really well known in the road scene. And so I've learned a lot. I came from mountain bike design at another company, I've been a lifelong mountain biker, but I ride a lot on the road and gravel, and so learned a lot about working with Vittoria in that they make super high TPI cotton tires. And the reason that they make these tires out of cotton is not because it's easier. It's definitely not easier. It's because the threads are thinner, so they're more flexible. So they don't bounce off of bumps in the road, which means they have less rolling resistance. And the same is true on a mountain bike tire. If you have like a double ply, super heavy duty casing and then like a big tread, it's not just the tread that makes the tire roll slow. It's actually the entire package because the system is actually less flexible.
Okay, so with that in mind, I think you kind of answered this. Would I be right in assuming that a lower TPI can also be on a cheaper tire, whereas the higher TPI, as well as performance, obviously tends to be more expensive? Is that one of the differences?
At the end of the day, an inexpensive tire is made to be inexpensive, right? That's going to be the chief concern when you're making that tire as a producer. So typically you'll see, a single compound. It won't be as boutique-y of a compound. It'll be just more basic. It'll be a lower thread count, to your point a minute ago. Typically, you'll see 26 TPI, something like that. The first thing actually you'll notice is the fact that it's a rigid bead, which is just literally a steel wire that goes around, a few times, rather than a folding bead. And they usually are not tubeless ready. And really, it's made with just lower quality materials, and actually a lot more like a car tire, as we spoke about a minute ago, in that way, where you're talking about a very rigid bead. It's heavier duty, and that way it's not made to maybe grip as good or roll as fast. But that's not the intent. The intent is really a price point. Yeah.
So tire casings. Now this has happened to me before. Why do tire casings wobble sometimes? I've definitely had this where maybe it feels like someone like a bike park will have really badly burped a tire, and the tire is still being seated but has a bit of a kink to it. Yeah.
So what you just described is probably the reason why your tire wobbled, right? So you went into a corner and you went and it burped. And what happened was that tire probably stretched. As we talked about a minute ago, tires are made to be, for bicycles, very lightweight. Even in the gravity sector, you're trying to make the tire, as light as you can, right? And so it's also a quality control thing. We don't see it typically very often, but I have seen it definitely elsewhere, and it's the kind of thing where sometimes the curing process is not even. Or something like that. So it can be a combination of factors, but typically what happens is when you overstress a tire, particularly a tubeless tire, where you have no other support in there, there's no insert or even a tube to help support the thing, and that bead interface is really tight and a positive interface, and the only thing that can happen is that the tire can stretch sometimes. Okay, great stuff. Has cleared that one up. Now you've got to clear this one up, because I've wanted to know this as well. Why is there so much variety in tyre sizing? Maybe someone's 2.2 is different to the next brand's 2.2. We all want to know that question. Yeah, no, it's a very loaded question. It's actually very timely. And so I appreciate that. So basically, there's something called ETRTO, and they create standards for tires and rims and how they're supposed to fit together. Basically, a certain width tire is supposed to go on a certain width rim within a given range, right? So a certain internal rim width will work for a certain range of tire widths within reason. Now, that's actually been recently updated. And so you're going to see sort of a revamp on this really this season, where rims have gotten wider. And so what happens when you put a tire, any tire, on a wider rim, the tire gets wider, right? It's pretty simple. So that is to say, if you had a tire that measured one way and it was designed on an ETRTO 21 internal rim. Now I know, to your viewers, people are like, 21, what is that about? Dude, that was the standard for many years for mountain bike. And that's, many of the tires that everybody listening to this has ridden were probably designed on a 21 or a 23 internal up until just a few years ago. And so what happens is rim manufacturers come out with a new wider rim, and it has all these benefits, and it totally does, don't get me wrong. But if you take one of those tires and put it on a wider rim, it's going to get, massively bigger. The general rule of thumb is for every 2 millimeters your rim grows, your tire will grow at least 1 millimeter. And that can actually get exaggerated as you go up in sizing. So there's a lot of different widths of tires to begin with, because cycling in general has grown into all these different subcategories. Just start there, right? I mean, back when you and I first started riding, it was like 1.95 or 2.1, and the first set of downhill tires I ever had were 2.2 Panaracers, right? And it was like massive, like a 2.2, will it fit my bike, And now it's like, that's smaller than cross country people use. It's insane. And so, fat tires came, and then people said, oh, I want some of that performance, but without all that heft. So we're going to make plus tires. And then people said, even plus tires are too big. I want to make something that is like the size of almost like a downhill tire, but in more of a usable tread and casing. And that's really where you've seen like a lot of the new trail stuff come out, and even like how enduro tires have really progressed since then. In the meantime, cross-country tires have gotten larger. I mean, most of our teams are, running super lightweight 2.35s now. And, that's something that even 2 years ago, they absolutely no way would they do that.
The last two questions, I mean, bear in mind that we had hundreds of questions. I've tried to simplify this a bit, otherwise we'll be talking for hours. But this is the biggest. This is the biggest and the best bit. So I'm going to ask you both at the same time because I think they could go into the same territory. What's been the biggest innovation in the last 15 years?
Woo.
And where are we going next? Now, just before you answer, the things that spring to mind for me are those very early tyres. I think one of the earliest ones I rode was, I think it was the Tioga Farmer John. It was just a basic chevron tyre that had zero grip. It was really basic. And then you look at new tyres like your latest Mazda Tire, and it even looks complicated looking at it compared to how we've come a long way. I'll leave you to enlighten us on this.
No, man, for sure. Got to give it up to John Tomac, man. Farmer John's legend, like idol, the whole thing, right? But basically, they called it a Farmer John because it looks like a tractor tire. If you look at, literally farm tractors, it has that chevron. And it was funny because back in the day, people would take that chevron and they would run it pointing forward in front, and then they thought they'd be clever and run it, scooping in back, right?
Yeah.
Which is hilarious to me because as a designer, it's like you spend so much time and research and everything, and then someone spur of the moment's like, I'm just gonna do the exact opposite, and they flip it around. It's so funny. But I mean, hey, again, whatever works for you, whatever is fun, it's all good. But basically, tires back then, that tire, the Farmer John in particular, had just a big, broad chevron, right? And so there wasn't a lot of siping. It was a single compound. It was a bit hard. It was narrow by today's standards, and the rims it was designed on were also quite narrow. It was not a tubeless tire. It did not have a reinforced sidewall. All these things that we all just take for granted now. You just hop on your bike and the thing just hooks up, and you don't really know why. And it's all these reasons. The first tire I ever had was a Ritchie Megabyte on my 1991 Bridgestone MB5. And, tires from back then were definitely like your Farmer John, very much more simple. They may have come from some sort of a BMX influence. You saw a lot of that early on. And, but they weren't purpose built for mountain bike like they are now. As an example, I mean, you mentioned this Mazda Tire that we're launching. This Mazda Tire has a lot of traits that are really proven, but yet a lot of new stuff that is really cutting edge and taking what we've learned and applying it in a forward-thinking way. So knob layout's going to be kind of your classic moto layout. It's definitely something that a lot of other companies have done. We mentioned earlier, like some traits just repeat in an industry that work. Telescoping forks, riser bars, slack head angles, things like this. Tires are inherently, geometric patterns laid down on a casing. And so some things work better than others. And this has definitely like a familiar feel to it. But what we've done is taken a lot of the things that were standards and changed them. So for instance, you're going to see on one of the leading edges, a staircase instead of a ramp. A lot of tread designers historically have put ramps on the leading edge. And the reason is to make the tire roll faster, right? So you can have like a deeper tread, but without all that vibration maybe when it rolls. And it works to a point, but it really only works in the front because when you're trying to climb, that leading edge is your traction edge, right? That's what's trying to dig into the terrain or provide traction. So we wanted to make a tire that you could run front and rear. So the first thing we did was put a staircase there. So how does that do anything, right? What does that do? Well, basically at speed, it rolls like a ramp. It rolls right up the staircase. But when you're going slow and you're like in that moment where it's like super high load torque and you're trying to like fight for traction, you have multiple effective edges that are digging in rather than that ramp that would just slide away. The other thing you're going to notice is progressive sipe width, which is something that, we first did on, like, say, the Martello and the Moda, but with this, we've offered a lot more side channel room on this tire. And so side channel meaning the area between the center and the side treads. So dirt can pack in against that edge, and it works a lot like an edge of a ski, and it really has an aggressive bite. But it also, because of the progressive sipe width with that room, it builds upon the traction. So you have a really communicative feel at the limit. So oftentimes tires grip, 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 and then they don't grip, right? You go past that limit and there's nothing. Because of that progressive sipe width, the inside effective edge is really gummy.
Yeah, I can feel that even just by hand.
Yeah, I mean, if you notice, progressive sipe width, just to define it, basically means that the effective edge sipe is big, and then the sipe width tapers narrower. So, what we're trying to achieve here, the goal as a tread designer, is to try to basically make that side knob grip really well. So you have to basically make enough room for it to dig into terrain. You also have to make that effective edge gummy. But here's the trick. When you make that effective edge gummy, so oftentimes in other tires, from our competitors particularly, the knob will just fold over. And that's oftentimes where you lose traction at the limit. But with this, it's supported on the outside of the knob, but the inside of, that effective edge is really nice and sticky. So that's kind of the quick way to say it, progressive sipe width. So progressive sipe width, that staircase, and then, obviously, advancements in compounds to answer the question. I mean, compounds compared to what they used to be are just night and day different. Like we said earlier, a lot of compounds might have just been natural rubber or just kind of like a single compound synthetic. Compounds now are optimized for wet weather use, which is to say they cut through that top layer of wetness, and they really are made to not just hydroplane that way. There are also, multiple compounds. So, by using 4C, we can basically put down 4 different compounds. So you have a base compound and a surface compound. And so the base compound provides a tremendous amount of stability. And then the surface compound that's actually hitting your terrain is nice and tacky and gummy. So you have stability in the tread. Your knob doesn't just flop over and rip off. It's more durable that way. It actually rolls faster too. So you have a lot of benefits from layering the compounds that way. And why are there 4? Well, you need a base and a surface in the center, and then a base and the surface on the side as well. So for that reason, we use 4 different compounds. And then, lastly, I'll say that kind of compound materials, everybody has their secret sauce, and we totally respect that. There's a lot of good products out on the market right now. We've decided to use graphene in our compound. And it's something that, companies in other industries have used, and we were the first to do it in rubber. We found that it positively affected the elastomeric properties of the rubber so that it rolled faster, wore better, and it provided better wet weather grip. And we could have put a flashy marketing name on it, but we really just wanted you to be able to look it up. So we just literally tell you what's in the compound. And I think we're really the only company that does that. Some people ask me, is this marketing? What's the deal with graphene? Particularly with graphene 2.0, the second version of it. And, my answer is always, when Popular Science writes an article about your bicycle tire compound, they don't care about bicycle marketing. It's because it's science and it does work. We won every time trial in the Grand Tours last year, and on our road tires. We've won World Mountain Bike Championships in cross country. And usually when people ride our tires, they like them. So it seems to work for us.
Awesome stuff. I'll tell you what, that's a lot of information there. Ken. I think that's awesome. Thanks for enlightening us, and thanks for answering so many great questions from our viewers. I think they'll be pretty stoked to that.
Yeah, man. Thank you so much for having me on. I'm a longtime fan, and it's been great to work with you guys. So excited to see what you guys think about this new Mazda Tire, and hopefully we can get on the trail soon.
100%. Take care, Ken. I'll see you soon.
Yeah. Thanks, man.
Well, there you go. That answers just about every question that we had in regards to tyre technology. If you didn't get around to answering your question, let us know in the comments underneath and we'll put together a special Ask GMBN Tech to cover all of the rest of them. Sorry about the sort of slightly patchy signal at times. It's just the way we've got used to working, unfortunately, in recent times. But nonetheless, if you want to learn a bit more about tyres and you want to see how they're manufactured, I was lucky enough to visit the factory in Thailand. I actually got to see the rubber come out of the trees and go all the way through the production line. That video's over there somewhere. So, well, check it out. Thanks a lot for watching, everyone. See ya.